Today we're going to start this video also by talking a little bit about complement rules of probability. Last time we started in the previous video. So always the probability of the event plus the probability of the complement of the event is equal to 1. And we can say the complement of the event, the probability of not the event. So we saw also the example where we had jars where we have 4 red balls and 5 blue ones. So if I select a ball at random, the probability that this ball will be red is 4/9, and the probability that this ball will be blue or not red is 5/9. Notice if we add these two fractions is 1. Also, we can find the probability of the complement of the event by subtracting the probability of the event from 1. If you are dealt one card from a standard deck of cards, find the probability you are not dealt a king. First of all, the probability of a king is 4/52, so the probability of not dealt with a king is 1 minus 4/52. That's 48/52. If you are dealt one card from a standard deck of cards, find the probability you are not dealt a heart. The probability of a heart is 13/52. Therefore, the probability of not dealt with a heart is 1 minus the probability of heart, that's 39/52. If you are dealt one card from a standard deck of cards, find the probability that you are not dealt a picture card. So the probability of getting a picture card is 12/52. Therefore, the probability of not a picture card or not dealt with a picture card is going to be 40/52. We have a pie graph that shows the number of US age driver by age group. So those who have an age greater or equal than 83%, those who have an age between 70 and 79, their percentage is 7%. Those who have an age 60 to 69, their percentage is 10%, etc. Now, if a driver is randomly selected from this population, find the probability that this person is not in the 30 to 39 age group. So the 30 to 39 age group, we have it as 21%. So if we want the probability is not, we're going to subtract that sector or the percentage of that sector from 1. So instead of adding all the percentages we have, except for this one, it's much easier to subtract the 21% from 1, and that's 79%. Now we need to know that if we select a person at random, what's the probability of that person is less than 80 years old? So we have the percentage of the age group who has age greater or 80 as 3%. So now, instead of adding the other sectors, it's much easier to subtract the 3% from 1 if I want the probability of a person selected at random, his age is less than 80. So that's 1 minus the probability of 80 or older, and that's 97%. Now, addition in probability is the probability of A or B. Now, first of all, if events A and B are mutually exclusive, disjoint, it means they cannot occur at the same time. We just add their probabilities. Otherwise, if they have something in common, we need to subtract that intersection. Example of mutually exclusive events: when it's sunny and raining, These are mutually exclusive events. Not mutually exclusive, it means when I pick an ace and when I pick a spade card, an ace can be spade. If a card is selected at random from an ordinary deck of cards, what's the probability of selecting a queen or an ace? Now, we have 4 aces, 4 queens, therefore the probability of a queen or an ace is 8 out of 52. We just add the two probabilities. If a card is selected at random from an ordinary deck of cards, what's the probability that this card is a queen or a red card? So we have 4 queens and we have 26 red cards, but we have 2 queens that are red. Therefore, the probability of a queen or a red is going to be the probability of a queen plus the probability of red minus the probability of queen and red. So that's 28 out of 52. If a card is selected at random from an ordinary deck of cards, what's the probability of selecting a heart or a picture card? So we have 13 hearts and we have 12 picture cards, but 3 of the picture cards can be hearts. So the probability of a heart or a picture card is going to be as follows. A 3 or 10, we have 4 10s, 4 3. They don't have anything in common, therefore we just go ahead and add the probability. We have, if the probability of A is given as 0.37 and the probability of B is 0.25 and the probability of A or B as 0.62, are events A and B mutually exclusive? So we have the formula and let's plug everything we have, substitute all the variables by the numbers we have. Upon solving for the probability of A and B, we notice that it's 0. So if the intersection is 0, it means A and B are disjoint events or mutually exclusive. Odds in favor of the event is the probability of E over the probability of not E. Odds against the event is the probability of not E over the probability of E. So first, let's review the probability of an event and the probability of not event. When I roll a dice, what's the probability of getting a 3? It's 1 over 6. And what's the probability of not getting a number 3? That's 5 over 6. Or 1 minus 1 over 6, which is 5 over 6. Now, find the odds in favor of rolling a 3 when we roll a 6-sided die. So the probability is 1 over 3, and the probability of not 3 is 5 over 6. So odds in favor rolling a 3, that's 1 over 6 over 5 over 6. And this is the same as division of fractions. So we have 1 over 6 divide 5 over 6. So that's why we kept the first one, changed the second one, and flipped the second one. So that's 1 to 5. Find the odds against rolling a 6. Again, the probability of getting 6 is 1 over 6, and the probability of not getting a 6 is 5 over 6. Therefore, the odds against rolling a 6 is going to be 5 to 1. We have a flower with congruent colored petals. R stands for red, and B for blue, and Y for yellow. If a petal is selected at random, let E be the probability of getting a red petal. Find the odds in favor of getting a red petal. First of all, the probability of getting red is 2 out of 6, and the probability of not getting red is 4 out of 6. Therefore, the odds in favor of E are going to be 1 to 2. Now we need to find the odds against getting a red petal. So that's going to be 2 to 1. If the odds in favor of event E are A to B, then the probability of the event is given by A over A plus B. If the odds in favor of a horse winning the race are 3 to 7, what is the probability that this horse will win the race? So my A is 3 and my B is 7, therefore the probability is going to be 3 over 10. If the odds in favor of a ticket winning a bet are 5 to 8, what's the probability that this ticket will win the bet? So that's going to be 5 over 13. The odds against a particular horse winning a race are 17 to 1. Find the odds in favor of the horse winning the race. Just reverse the numbers, so that's going to be 1 to 17. Find the probability of the horse winning the race. That's going to be 1 over 18.